Welcome to another quiet hour of reflection and reason. Tonight, we'll let our minds stretch out across time, theory, and the quiet awe of science itself. Whether you're drifting off or simply craving calm, I'm so glad you're here. Let me know where you're listening from and whether the stars are out or the sky is still light where you are. If you enjoy peaceful, thoughtful stories about the universe and beyond, I hope you'll subscribe. There's so much to wonder at together. Let's begin our journey with something that might surprise you. That speck of dust dancing in a sunbeam streaming through your window, that bit of lint on your sweater, even the gentle accumulation on your bookshelf. They're all distant cousins of something far more magnificent. They're echoes of a process that's been building worlds, stars, and life itself for over 13 billion years. You see, not all dust is created equal. Most of the dust in your home comes from shed skin cells, fabric fibers, and particles that drifted in from outside. But cosmic dust, that's something entirely different. Cosmic dust is the universe's original construction material, forged in the hearts of dying stars and scattered across the vast emptiness of space like seeds waiting to grow into something extraordinary. These cosmic particles are almost impossibly small, typically ranging from a few molecules to about the width of a human hair. To put that in perspective, if a grain of cosmic dust were the size of a marble would be the size of the Earth. They're so tiny that billions of them could dance on the head of a pin, and you'd never know they were there. But here's what makes them truly magical. Despite their size, these microscopic wanderers are the reason you exist. Every atom in your body, except for hydrogen and some helium, was forged inside a star and then scattered into space as cosmic dust when that star died. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it began as stardust drifting through the cosmic void. Carl Sagan famously said, "We are made of star stuff," and he wasn't being poetic. He was being scientifically precise. The elements that make up your body were literally created in the nuclear furnaces of ancient stars, expelled into space, and eventually gathered together to form the Earth and everything on it, including you. This cosmic dust doesn't just float aimlessly through space like cosmic lint. It has jobs to do, cosmic construction projects that span millions of years. When these tiny particles drift through the cold reaches of interstellar space, they begin to stick together, drawn by the gentle pull of gravity and electromagnetic forces. Slowly, patiently, they accumulate in vast clouds called nebulae. These nebulae are like cosmic nurseries, stellar maternity wards, where new stars are born from the gathered dust and gas. The process is so gradual, it would make a glacier seem hasty. Over hundreds of thousands of years, the dust and gas in these clouds begin to clump together, forming denser and denser regions. Eventually, these regions become so dense and hot that nuclear fusion ignites, and a new star blazes to life. But the story doesn't end there. As stars live their lives, burning bright for millions or billions of years, they continue to cook up heavier elements in their cores. When these stars eventually die, many of them do so spectacularly, in explosions called supernovae that outshine entire galaxies for weeks. These cosmic fireworks scatter the newly minted elements across space as fresh cosmic dust, ready to begin the cycle anew. It's a beautiful cosmic recycling program that's been running since the universe was young. The dust from one generation of stars becomes the building material for the next generation, and each cycle creates more complex elements, more interesting chemistry, more possibilities for the universe to build something new and wonderful. Some of this cosmic dust has been on incredible journeys before arriving here. Particles in our solar system might have originated in stars that died billions of years ago, traveled across the galaxy, witnessed the formation of countless other star systems, and finally found their way to our little corner of the cosmos. They're cosmic veterans, carriers of stories from the deep past of the universe, and they're still arriving. Right now, as you listen to this, Earth is being gently dusted with cosmic particles. About 40 tons of cosmic dust settles onto our planet every single day. It's so fine, so dispersed that you'd never notice it, but it's there, a constant gentle rain of stardust adding to our world grain by microscopic grain. This cosmic dust isn't just ancient history either. It's actively shaping the future. In the cold, dark regions between stars, cosmic dust serves as a cosmic matchmaker, helping atoms find each other and form the first simple molecules. These dust grains act like tiny chemistry labs, providing surfaces where atoms can meet, stick together, and begin the complex chemical processes that might one day lead to life. The story of cosmic dust is also the story of how complexity emerges from simplicity. In the early universe, there were only the lightest elements: hydrogen, helium, and a trace of lithium. Everything else, every element more complex than those primordial three, had to be built inside stars. The carbon that forms the backbone of every living molecule, the oxygen that you breathe, the silicon in computer chips, the gold in jewelry, all of it began as stellar alchemy and ended up as cosmic dust. This process of stellar nucleosynthesis, the creation of elements inside stars, is one of the most important stories in the history of the universe. It's how the cosmos went from being a simple soup of the lightest elements to the rich, complex chemical wonderland we see today. Every element in the periodic table, beyond hydrogen and helium, has a stellar birth certificate. As we drift deeper into this cosmic tale, it's worth pausing to marvel at the patience of the universe. The processes we're describing don't happen quickly. A typical star might live for millions or billions of years before it dies and scatters its elemental gifts into space. The cosmic dust it creates might drift through the galaxy for millions more years before finding its way into a new star system. The universe operates on timescales that dwarf human experience, but the results of this patience are extraordinary. Tonight, as you prepare for sleep, you're surrounded by the products of this cosmic construction project. The pillow beneath your head contains elements forged in ancient stars. The air you breathe carries atoms that have journeyed across the galaxy. The very thoughts forming in your mind are made possible by chemistry that began billions of years ago in the hearts of dying suns. So rest easy, knowing that you are not separate from the cosmos, but intimately connected to it. You are the universe experiencing itself, a temporary arrangement of stardust that has somehow learned to wonder about its own origins. And tomorrow, when you see dust motes dancing in a sunbeam, you might remember that they're distant relatives of the cosmic dust that built the stars, the planets, and you. The universe whispers its secrets in the language of dust. We've journeyed through the grand architecture of time and the theater of dreams, but now let us drift towards something far smaller, yet infinitely more profound. Tonight, we explore the cosmic dust and stardust that surrounds us, fills us, and tells the oldest story in the universe. These particles, invisible to the naked eye, are the universe's smallest builders, constructing everything from the grandest galaxies to the gentlest thoughts floating through your mind as you listen. Imagine for a moment that you could shrink yourself down, smaller than the width of a human hair, smaller than a bacterium, smaller still until you're floating alongside the tiniest wanderers of space. Here, in this microscopic realm, you'd find yourself surrounded by cosmic dust particles, each one a fragment of stellar history, a microscopic time capsule carrying the signature of ancient stars. These particles are so small that millions of them could dance on the head of a pin, yet collectively They outweigh all the planets in our solar system combined. But what exactly is cosmic dust? It's not the dust that settles on your bookshelf or drifts lazily through afternoon sunlight, though the comparison isn't entirely wrong. Cosmic dust consists of tiny, solid particles suspended in space, ranging from a few molecules to grains about the size of cigarette smoke. Some are made of silicates, like microscopic fragments of glass. Others are composed of carbon compounds, organic molecules that form the building blocks of life. Still others contain metals, crystallized remnants of stellar cores that once burned at temperatures exceeding 10 million degrees. These particles didn't simply appear, they were forged in the hearts of dying stars, scattered across the cosmos in the final moments of stellar death, and have been wandering ever since. Every grain carries within it the nuclear fingerprint of its stellar parent, a chemical signature that tells us where it came from, how old it is, and what elements it contains. In a very real sense, cosmic dust particles are stellar obituaries written in atoms, drifting through space for millions or billions of years before finding their way to us. The story begins in the core of a massive star, where temperatures and pressures are so extreme that hydrogen nuclei fuse together, creating helium and releasing the energy that makes stars shine. But fusion doesn't stop there. As the star ages, it begins fusing helium into carbon, carbon into oxygen, oxygen into silicon, and silicon into iron. Each step requires higher temperatures and pressures, and each step creates heavier elements that never existed in the early universe. This process, called nucleosynthesis, is how stars manufacture the periodic table one element at a time. When these massive stars reach the end of their lives, they don't simply fade away like candles in the wind. Instead, they explode in brilliant supernovae, events so energetic they can outshine entire galaxies for weeks or months. In these cataclysmic moments, the star's outer layers are blasted into space at speeds of thousands of kilometers per second, carrying with them all the elements the star created during its lifetime. The shock waves from these explosions are so powerful they can trigger the formation of even heavier elements, creating gold, platinum, uranium, and other rare metals in the moments of stellar death. But the explosion is only the beginning of the dust's journey. As the hot gas expelled by the supernova begins to cool and expand, the atoms within it start to condense, much like water vapor condensing into droplets on a cold window. Carbon atoms clump together to form tiny graphite grains. Silicon and oxygen combine to create microscopic crystals of silicate. Iron atoms cluster into metallic particles smaller than viruses. Within a few thousand years, what was once the interior of a star has become an expanding cloud of gas and dust, enriching the surrounding space with elements that didn't exist when the universe was young. This is where our story takes a beautiful turn, because this stellar dust doesn't simply drift aimlessly through space. Instead, it becomes the raw material for new generations of stars and planets. Gravity, that patient sculptor we've met before, slowly draws these enriched clouds together. Over millions of years, the dust particles act as condensation nuclei, helping gas molecules stick together and form ever larger clumps. The dust also plays a crucial role in cooling these clouds, radiating away heat and allowing them to collapse under their own gravity. Eventually, these dust-enriched clouds become dense enough to ignite nuclear fusion, and a new star is born surrounded by a disk of leftover material. Within this disk, dust particles continue their construction work, sticking together grain by grain to form pebbles, then rocks, then asteroids, and finally planets. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of these elements were once cosmic dust, forged in the heart of an ancient star and scattered into space billions of years ago. But the dust's journey doesn't end with planetary formation. Even now, as you sit listening to these words, cosmic dust is gently falling all around you. Every day, Earth intercepts roughly 100 tons of cosmic dust, particles so small they drift down through our atmosphere like microscopic snow. Most of these particles are so tiny they never reach the ground intact, instead, burning up in brief flashes we sometimes see as meteors. But the smallest ones, those less than a tenth the width of a human hair, survive the journey and settle quietly onto every surface on Earth. Some of this dust comes from comets, those dirty snowballs that venture into the inner solar system and leave glowing trails of sublimated ice and ancient dust in their wake. Other particles come from asteroids, gradually worn down by countless collisions over billions of years. And some, the most exotic of all, are interstellar dust grains that formed around other stars entirely, wandering through space for millions of years before being captured by our solar system's gravitational embrace. Scientists have learned to recognize these interstellar visitors by their unusual isotopic signatures, chemical fingerprints that don't match anything formed in our solar system. These grains are literally alien, fragments of stellar explosions that occurred long before our sun was born. They've traveled across the galaxy, survived passage through interstellar space, and somehow found their way to Earth, where patient researchers extract them from meteorites and Antarctic ice cores with tools so precise they can manipulate individual atoms. What makes this story even more remarkable is the sheer scale of time involved. Some of the dust grains falling on Earth today began their journey when the universe was less than half its current age. They've witnessed the formation and destruction of countless stars, drifted through spiral arms and stellar nurseries, survived shocks from supernovae, and gravitational perturbations from massive black holes. Each particle is a time traveler, carrying information about cosmic environments that existed billions of years before Earth formed. The composition of cosmic dust tells us profound things about the history of the universe. The earliest dust, formed when the universe was young, contains only the simplest elements: hydrogen, helium, and traces of lithium left over from the Big Bang. But as generations of stars lived and died, each adding their nuclear ashes to the cosmic mix, the dust became increasingly complex. Later generations of dust contain carbon and oxygen, then silicon and iron, then the full spectrum of elements we see today. This gradual enrichment of cosmic dust mirrors the chemical evolution of the entire universe. The first stars, formed from pristine hydrogen and helium, created the first heavy elements. When they exploded, they seeded space with dust containing carbon, oxygen, and other light metals. These enriched clouds formed new stars that could create even heavier elements, which in turn were scattered by subsequent explosions. Generation after generation, the universe became more chemically complex, and this complexity is recorded in the cosmic dust that surrounds us. The dust also plays a crucial role in the ongoing story of star formation. Without dust, interstellar clouds would be too hot to collapse under their own gravity. The dust particles absorb ultraviolet radiation from nearby stars and re-emit it as infrared radiation, cooling the gas and allowing gravity to take hold. In this sense, cosmic dust is not just the product of stellar death, it's also the midwife of stellar birth, helping new stars come into existence by creating the conditions necessary for gravitational collapse. In the densest regions of space, where dust is particularly abundant, we find stellar nurseries regions where dozens or hundreds of new stars are being born simultaneously. The dust in these regions is so thick it blocks visible light entirely, creating dark nebulae that appear as holes in the star-filled sky. But viewed in infrared light, which can penetrate the dust, these regions glow with the heat of star formation. The dust that once cooled these clouds now glows warmly, as it's heated by the very stars it helped create. This cosmic recycling program has been running for over 13 billion years, turning the simple hydrogen and helium of the early universe into the rich chemical tapestry we see today. Every time you take a breath, you're inhaling atoms that were once inside a star. Every time you touch something, your fingers make contact with elements that were forged in stellar cores and scattered by supernovae. The very atoms in your DNA, the molecules in your morning coffee, the silicon in your smartphone, all of these were once cosmic dust, drifting through space for eons before finding their way to Earth. But perhaps the most poetic aspect of cosmic dust is how it connects us to the deepest history of the universe. These particles are not just building blocks, they are storytellers, carrying within their crystalline structures the memory of stellar explosions, interstellar journeys, and the gradual construction of complexity from simplicity. When astronomers study dust grains under powerful microscopes, they're reading the autobiography of the cosmos, written in atoms and preserved in particles smaller than bacteria. As we drift towards sleep, surrounded by this invisible rain of stardust, we can take comfort in knowing that we are not separate from the universe, we are part of it, intimately and eternally. The calcium in our bones was forged in stellar cores that burned billions of years ago. The iron in our blood was scattered by supernovae that lit up ancient skies. We are not merely observers of the cosmic story, we are characters in it, built from the same stellar ashes that continue to drift down around us like the gentlest, most persistent snow. Tonight, as you rest, remember that you are surrounded by time travelers' particles that have journeyed across the galaxy to be here, in this moment, sharing their ancient light with your dreaming mind. The universe's smallest builders are still at work, still constructing, still carrying forward the grand project of turning simple elements into complex beauty. And somewhere in the vast darkness, new stars are being born from dust, continuing the cycle that connects every grain of sand to every distant galaxy, every breath to every burning star. Welcome back to The Sleepy Scientist, where curiosity finds its softest voice and science gently carries you toward dreams. I'm so glad you're here tonight, wherever you may be listening from, whatever quiet corner of the world has brought you to this moment. Tonight, we continue our cosmic journey through the universe's most fundamental building blocks. We've already explored how cosmic dust and stardust form the very foundation of everything we see, how these tiny grains, smaller than a whisper, carry the chemical signatures of ancient stars across billions of years. We've learned that these particles serve as cosmic time capsules, traveling through the vastness of space to arrive here on Earth, contributing not just to planetary formation, but to the rich chemical tapestry that makes life itself possible. But there's so much more to this story. The universe you see is remarkably efficient at recycling. Nothing is ever truly lost, nothing ever truly wasted. Every atom in your body, every breath you take, every thought that drifts through your mind as you settle into sleep tonight, all of it has been on an extraordinary journey that spans the entire history of the cosmos. Let's continue our gentle exploration into how this cosmic recycling works, how the universe transforms and reuses its most precious materials again and again, creating beauty from destruction and new beginnings, from ancient endings. When a star reaches the end of its life, when it has burned through all the fuel in its core and can no longer sustain the nuclear fires that have kept it shining for millions or billions of years, it doesn't simply disappear. Instead, it becomes a cosmic philanthropist, giving away everything it has spent its lifetime creating. For smaller stars, stars roughly the size of our sun or a bit larger, this donation happens relatively gently. These stars puff away their outer layers in beautiful, colorful clouds called planetary nebulae. Despite the name, these have nothing to do with planets. They're called planetary nebulae because when astronomers first discovered them through early telescopes, they appeared round and disc-like, resembling distant planets. But they're actually something far more magnificent. Picture this: A dying star, having exhausted the hydrogen fuel in its core, begins to swell and cool, becoming what we call a red giant. The star's outer layers become loosely bound, like a coat that no longer fits properly. Solar winds, streams of charged particles flowing from the star's surface, begin to blow these layers away into space. What remains is the star's hot, dense core, now called a white dwarf, sitting at the center of an expanding shell of glowing gas. This gas, enriched with all the heavy elements the star created during its lifetime, carbon, nitrogen, oxygen, and many others, spreads out into space at speeds of tens of kilometers per second. But it doesn't travel in a straight line. Magnetic fields twist and shape the expanding gas into intricate patterns, rings, jets, and helical structures that can stretch for light years across space. The white dwarf at the center, still incredibly hot with surface temperatures reaching 100,000 degrees Celsius or more, bathes this expanding shell in ultraviolet radiation. This energetic light causes the gas to fluoresce, to glow in brilliant colors. Hydrogen glows red, oxygen shines green and blue, nitrogen adds deeper reds and purples. The result is some of the most breathtakingly beautiful objects in the universe, cosmic flowers blooming in the darkness of space. The Ring Nebula in the constellation. Lyra looks like a giant eye staring back at us from 2,000 light-years away. The Helix Nebula, sometimes called the Eye of God, spans nearly half the apparent size of the full moon in our sky, though it's so faint you need a telescope to see it. The Cat's Eye Nebula displays intricate knots and jets of gas, like cosmic calligraphy written in light. But these aren't just pretty pictures. They're active recycling centers, cosmic distribution networks spreading the products of stellar nucleosynthesis throughout the galaxy. The carbon in these expanding shells will one day become part of new stars, new planets, maybe even new forms of life. The oxygen will become part of water molecules and the atmospheres of distant worlds. The nitrogen will help build the complex molecules that make life possible. For more massive stars, those at least 8 times the mass of our Sun, the recycling process is far more dramatic. These stellar giants live fast and die young, burning through their fuel in just a few million years, rather than the billions of years smaller stars enjoy. When they reach the end of their lives, they don't gently puff away their outer layers. Instead, they explode. A supernova is one of the most violent events in the universe. A stellar explosion so powerful it can briefly outshine an entire galaxy containing hundreds of billions of stars. In the space of just a few seconds, the star's core collapses from the size of the Earth to just 20 kilometers across, creating a neutron star so dense that a teaspoon of its material would weigh as much as Mount Everest. The shock wave from this collapse rebounds outward, ripping through the star's outer layers and blasting them into space at speeds of 10,000 kilometers per second or more. The energy released in this explosion is almost incomprehensible. In those few seconds, the supernova releases more energy than our Sun will produce in its entire 10 billion year lifetime. But supernovae do more than just spread existing elements throughout space. The extreme conditions in the explosion, temperatures reaching billions of degrees, and pressures millions of times greater than at the center of the Sun, allow nuclear reactions that can't happen anywhere else in the universe. These reactions create the heaviest elements, things like iron, nickel, cobalt, and all the elements heavier than iron. The gold in your jewelry, the silver in your coins, the platinum in your electronics, all of these were forged in the heart of an exploding star. Every atom of these precious metals was created in those few seconds of unimaginable violence and then scattered into space, waiting billions of years to eventually find its way into the rocky planets where future civilizations would discover and treasure them. The shockwave from a supernova doesn't just disperse material, It compresses the gas and dust in nearby regions of space. This compression can trigger the formation of new stars, turning stellar death into stellar birth. In a very real sense, supernovae are midwives to the next generation of stars, using the violence of their destruction to nurture new creation. This supernova-triggered star formation creates what astronomers call stellar associations, groups of young, hot stars that formed from the same compressed gas cloud. These associations gradually drift apart over millions of years as their member stars follow their individual orbits around the galaxy. But for a time, they light up their neighborhood with brilliant blue-white light. The Orion Nebula, visible to the naked eye as the fuzzy star in Orion's sword, is one such stellar nursery. The bright stars at its heart, the trapezium cluster, are less than 1,000,000 years old, cosmic newborns whose intense radiation is illuminating the surrounding gas and dust from which they formed. This nebula is actively creating new stars even now, with dense knots of gas and dust slowly collapsing under their own gravity to ignite nuclear fusion and join the stellar community. But the recycling doesn't stop with individual stars and nebulae. On larger scales, entire galaxies participate in this cosmic exchange program. Galaxies don't exist in isolation. They're part of a vast cosmic web of dark matter and ordinary matter that connects everything in the universe. Gas flows along the filaments of this cosmic web, streaming from one galaxy to another, carrying with it all the elements created by generations of stars. When galaxies collide, a process that happens more often than you might think, their gas clouds smash together, creating shock waves that compress the gas and trigger massive bursts of star formation. Our own Milky Way galaxy is currently in the process of consuming several smaller satellite galaxies. The Sagittarius dwarf galaxy is being slowly torn apart by our galaxy's gravity, its stars scattered in long streams that wrap around the Milky Way like ribbons. The gas from this disrupted galaxy mixes with our own, bringing new material to fuel future generations of stars. In about 4 billion years, the Milky Way will collide with the Andromeda Galaxy, our nearest large neighbor. This collision will trigger a massive burst of star formation as the gas clouds in both galaxies are compressed and heated. New stars will be born at rates hundreds of times faster than normal, briefly turning the merged galaxy into what astronomers call a starburst galaxy. Even black holes, those gravitational monsters that seem to devour everything around them, play a role in cosmic recycling. When matter falls into a black hole, it doesn't simply disappear. As it spirals inward, it heats up to millions of degrees, glowing so brightly it can be seen across billions of light years. Some of this material never actually crosses the black hole's event horizon. Instead, it gets caught up in powerful magnetic fields and shot out in jets of plasma that can extend for hundreds of thousands of light years. These jets, moving at nearly the speed of light, plow into the surrounding gas and dust, heating it and stirring it up. This process, called feedback, regulates star formation in galaxies. Too much star formation too quickly would use up all the available gas, leaving none for future generations. Black hole feedback acts like a cosmic thermostat, keeping star formation at a sustainable rate. The most remarkable thing about all of this recycling is how thorough it is. Astronomers estimate that the average atom in your body has been through at least one, possibly several, stellar recycling events. The calcium in your bones was created in a dying star that puffed away its outer layers billions of years ago. The iron in your blood was forged in a supernova explosion and scattered into space long before our solar system even existed. This means you are quite literally made of recycled star material. You are the universe's way of knowing itself, a temporary arrangement of cosmic dust that has somehow achieved consciousness and is now contemplating its own origins. Every thought you think, every emotion you feel, every dream you dream tonight is made possible by atoms that have been on an incredible journey through space and time. The hydrogen in the water in your body is even older than the stars. Most of it was created in the first few minutes after the Big Bang, when the universe was hot and dense enough for nuclear fusion to occur everywhere at once. That hydrogen has been recycling for nearly 14 billion years, sometimes locked up in the cores of stars, sometimes drifting free in the emptiness between galaxies, sometimes frozen in comets at the edge of solar systems. The oxygen you breathe was created in the core of a massive star that lived and died before our sun was born. For millions of years, that oxygen was trapped inside the star, participating in the nuclear reactions that kept the star shining. Then, in the final moments of the star's life, it was blasted into space in a supernova explosion, where it drifted for eons until it was incorporated into the gas cloud that would eventually become our solar system. Even the elements that make up our planet have been recycled multiple times. The Earth formed 4.6 billion years ago from a disk of gas and dust surrounding the young sun. This material had already been processed through at least one, possibly several, generations of stars. The rocky planets couldn't have formed at all without this stellar recycling, because the Big Bang only created hydrogen, helium, and tiny amounts of lithium. Everything else, all the silicon, magnesium, aluminum, and iron that make up the bulk of rocky planets, had to be created inside stars and then distributed through space. The process continues today. Every year, about 40,000 tons of cosmic dust falls to Earth, mostly tiny particles so small they drift gently through the atmosphere like microscopic snow. This dust carries with it the chemical signatures of distant stars, adding new material to our planet's inventory. Some of this dust comes from comets, which are themselves collections of pristine material from the early solar system. Other particles come from asteroids, the leftover building blocks of planets that never quite formed. Occasionally, larger chunks of recycled cosmic material make it to Earth's surface as meteorites. These space rocks provide us with samples of other worlds, other processes, other chapters in the story of cosmic recycling. Some meteorites are pieces of asteroids that have been wandering the solar system for billions of years. Others are fragments of the Moon or Mars, blasted into space by ancient impacts and eventually captured by Earth's gravity. The most exotic meteorites come from the hearts of dead stars. These are tiny, incredibly dense grains of silicon carbide and other materials that condensed in the cooling gas around dying stars billions of years ago. They drifted through space for eons before being incorporated into the solar nebula and eventually ending up in meteorites that we can study in laboratories today. By analyzing these pre-solar grains, scientists can learn about the nuclear processes that occurred in individual stars that died long before our sun was born. It's like cosmic archaeology, using microscopic fossils to reconstruct the history of stellar nucleosynthesis. Each grain tells a story of temperature, pressure, and nuclear reactions that occurred in a specific star at a specific time in the distant past. The recycling extends beyond our own galaxy. The universe is full of intergalactic gas, material that has been expelled from galaxies by supernovae, stellar winds, and black hole activity. This gas, enriched with heavy elements created by stars, can be captured by other galaxies, bringing new chemical diversity to their stellar populations. Galaxy clusters, the largest gravitationally bound structures in the universe, contain vast amounts of this intergalactic gas. The space between galaxies in these clusters is filled with hot X-ray emitting gas that has been enriched by billions of years of stellar processing. This gas serves as a reservoir of raw material that can feed future star formation as it cools and condenses. Even the cosmic microwave background radiation, the afterglow of the Big Bang that fills all of space, carries information about the early universe's composition. By studying tiny variations in this radiation, Astronomers can map out the distribution of matter when the universe was only 380,000 years old, long before the first stars formed. This gives us a baseline against which to measure how much the composition of the universe has changed due to stellar nucleosynthesis and recycling. The story of cosmic recycling is ultimately a story of connection. Every atom, every molecule, every grain of dust is connected to every other through this vast network of stellar birth, death, and rebirth. The carbon atoms in your DNA may have been created in different stars, at different times, in different parts of the galaxy, but they all ended up here, in you, as part of this temporary but remarkable arrangement we call life. This perspective can be both humbling and comforting. Humbling because it reminds us that we are just temporary custodians of this recycled star material, brief patterns in the cosmic flow that will eventually be dissolved and redistributed to create new patterns, new possibilities, new forms of beauty and complexity. Comforting because it connects us to everything else in the universe, making us part of a story that is far larger and more ancient than any individual life or civilization. When you look up at the night sky, you're not just seeing distant lights, you're seeing your relatives, the stellar furnaces that created the elements in your body. You're seeing the recycling centers where cosmic dust is being processed and redistributed. You're seeing the past, present, and future of cosmic evolution all at once. The dust and gas between the stars, barely visible to our eyes but revealed in stunning detail by infrared telescopes, represents the raw material for future worlds, future life, future consciousness. Somewhere in that cosmic dust are the atoms that will one day be part of beings we cannot imagine, living on worlds not yet formed, under the light of stars not yet born. And so the cosmic recycling continues, as it has for nearly 14 billion years, as it will for trillions of years to come. Stars will continue to live and die, scattering their processed elements into space. New stars will form from this enriched material, creating even more complex chemistry. Planets will condense from the dust, and on some of those planets, the atoms will organize themselves into patterns of extraordinary complexity and beauty. We are part of this ongoing story, temporary but significant chapters in the universe's long book of recycling and renewal. Tonight, as you drift towards sleep, remember that you are made of stars, that you carry within you the history of cosmic evolution, and that someday, the atoms that make you who you are will be recycled once again, becoming part of new stars, new worlds, new possibilities we can barely imagine. The universe wastes nothing. Every ending is a beginning. Every death feeds new life. Every scattered grain of stardust is a seed of future wonder. And you, dear listener, you are both the product of this ancient process and an active participant in it, a brief but beautiful arrangement of cosmic dust that has somehow learned to contemplate its own magnificent origins. Sleep well, knowing that you are connected to everything that has ever been, everything that is, and everything that ever will be. The stars are calling you home, and you are already there. Welcome back to The Sleepy Scientist, where curiosity meets calm and cosmic wonder settles gently into your evening. Tonight, we're continuing our journey through the vast tapestry of space, exploring how cosmic dust and stardust serve as the universe's most fundamental builders. Before we drift deeper into this celestial story, I'd love to know where in the world you're listening from tonight and what time it is in your corner of the cosmos. If you're finding peace in these quiet explorations of science, a gentle like or subscribe helps other wandering minds discover this tranquil corner of the universe. Now, as we've discovered in our previous chapters, every atom in your body was forged in the heart of a dying star, scattered across space through cosmic winds and stellar explosions, and eventually gathered into the rocky world we call home. But this story of cosmic recycling doesn't end with Earth's formation. It continues every single day, every single moment, as our planet drifts through space like a cosmic collector, gathering the universe's ancient debris. Right now, as you listen to these words, thousands of tons of cosmic dust are gently falling onto Earth. Most of these particles are smaller than the width of a human hair, invisible to the naked eye, yet they carry with them the chemical signatures of distant stars, the remnants of stellar nurseries, and the building blocks of worlds yet to be born. This cosmic snowfall has been constant for billions of years, a gentle reminder that Earth is not isolated in space, but intimately connected to the grand cycles of stellar birth and death that govern our galaxy. Think of it this way. Every breath you take contains atoms that were once part of a massive star, forged in nuclear furnaces millions of times hotter than the surface of the sun. The calcium in your bones was created in the explosive death of a massive star, scattered across space in a supernova that outshone entire galaxies. The iron in your blood was synthesized in stellar cores under pressure so extreme they defy earthly comprehension. You are not just made of star stuff, you are star stuff, temporarily organized into consciousness, briefly aware of your own cosmic heritage. This realization becomes even more profound when we consider the journey these atoms have taken. The carbon in your DNA didn't simply appear in your body. It began its journey in the core of a dying star, perhaps billions of years ago. When that star exhausted its nuclear fuel, it began to shed its outer layers, creating vast shells of glowing gas we call planetary nebulae. These ethereal structures, among the most beautiful objects in the universe, are essentially stellar funeral pyres, returning the elements forged in stellar cores back to the interstellar medium. But planetary nebulae represent only one pathway for cosmic recycling. The most massive stars, those with more than 8 times the mass of our Sun, end their lives in spectacular supernova explosions. These cosmic detonations are among the most energetic events in the universe, briefly outshining entire galaxies and releasing more energy in a few seconds than our Sun will produce in its entire 10 billion year lifetime. The shock waves from these explosions compress nearby gas clouds, triggering the formation of new stars, while the explosion itself scatters heavy elements across hundreds of light years of space. Some of these supernovae are so violent they create elements that cannot be forged in the peaceful nuclear furnaces of stellar cores. Gold, platinum, uranium, and other heavy elements require the extreme conditions found only in the collision of neutron stars or in the most energetic supernovae. The gold in your jewelry, the platinum in your electronics, the uranium that powers nuclear reactors, all were created in these cosmic catastrophes and then scattered across space to eventually find their way into the forming solar system 4.5 billion years ago. This process of stellar death and rebirth creates what astronomers call the cosmic chemical evolution. Each generation of stars is slightly richer in heavy elements than the last, because each new generation forms from gas clouds that have been enriched by the deaths of previous stellar generations. The first stars in the universe, those that formed just a few 100 million years after the Big Bang, were composed almost entirely of hydrogen and helium. They contained virtually no carbon, no oxygen, no silicon, no iron, none of the elements essential for rocky planets and life as we know it. But as these primordial giants aged and died, they began to seed the universe with heavier elements. Second-generation stars formed from gas clouds that contained trace amounts of carbon and oxygen. Third-generation stars had even more heavy elements, and so on, until eventually, after billions of years of stellar evolution, gas clouds became rich enough in heavy elements to form rocky planets like Earth. This cosmic enrichment process is beautifully illustrated by the different stellar populations we observe in our galaxy. The oldest stars, found primarily in the galactic halo and globular clusters, are metal poor, containing only tiny fractions of heavy elements. These ancient suns are the survivors of the galaxy's youth, formed when the Milky Way was still a chaotic collection of gas clouds and protostellar clusters. In contrast, younger stars like our Sun, found in the galactic disk, are relatively metal-rich, containing the accumulated heavy elements from billions of years of stellar evolution. Our Sun, in fact, is what astronomers call a third-generation star, meaning it formed from material that had already been processed through at least two previous generations of stellar birth and death. This explains why our solar system is so rich in heavy elements, rich enough to form not just rocky planets, but also the complex chemistry that makes life possible. The elements in your body have been recycled through multiple stellar generations, each cycle adding new complexity and new possibilities. But the story doesn't end with stellar death and birth. The universe is also filled with vast clouds of gas and dust called nebulae, stellar nurseries where new stars are constantly being born. These nebulae are often the remnants of dead stars, their material now serving as the raw ingredients for future stellar generations. The Eagle Nebula, the Orion Nebula, the Crab Nebula. Each of these magnificent structures represents a different stage in the cosmic recycling process. The Eagle Nebula, with its famous pillars of creation, shows us star formation in action. Dense columns of gas and dust, sculpted by stellar winds and radiation from nearby hot stars, are gradually collapsing under their own gravity to form new stellar systems. These pillars are being simultaneously destroyed and created, eroded by the very stars they're helping to birth, in a beautiful demonstration of the universe's creative destruction. The Orion Nebula, visible to the naked eye as the sword in the constellation Orion, is perhaps the most studied star-forming region in our galaxy. Here, we can observe the entire process of stellar birth, from the initial collapse of gas clouds to the emergence of fully formed stars surrounded by protoplanetary disks. The nebula glows with the light of newly born stars, their intense radiation ionizing the surrounding gas and creating the spectacular colors we see in astronomical images. The Crab Nebula represents the other end of the stellar life cycle. This expanding shell of gas and dust is the remnant of a supernova that was observed by Chinese astronomers in 1054 AD. The explosion was so bright it was visible during the day for several weeks, and the expanding shockwave continues to sweep through space nearly 1,000 years later. At the center of the nebula lies a pulsar, a rapidly rotating neutron star that represents the compressed core of the original massive star. These nebulae are not static structures, but dynamic, evolving systems that change over cosmic time. The gas and dust they contain is constantly being stirred by stellar winds, heated by radiation, compressed by shock waves, and enriched by the deaths of embedded stars. Over millions of years, these nebulae gradually disperse, their material mixing with the general interstellar medium and eventually being incorporated into new generations of stars and planets. The scale of this cosmic recycling is almost incomprehensible. Every second, somewhere in our galaxy, a star is being born from the ashes of its predecessors. Every few decades, a massive star explodes as a supernova, scattering its enriched material across light years of space. Every few million years, our solar system passes through different regions of the galaxy, encountering different concentrations of cosmic dust and gas, some of which rains down onto Earth's atmosphere as shooting stars and micrometeorites. This cosmic perspective transforms our understanding of what it means to be human. We are not separate from the universe, but integral parts of it. The atoms in our bodies have participated in cosmic processes that span billions of years and countless stellar generations. We are the universe becoming aware of itself. Cosmic dust temporarily organized into consciousness, briefly capable of contemplating our own origins and our place in the grand cosmic story. Every element in the periodic table, from the lightest hydrogen to the heaviest uranium, tells a story of cosmic evolution. Hydrogen and helium, the simplest elements, were forged in the first few minutes after the Big Bang, when the universe was still hot enough for nuclear fusion to occur throughout space. Carbon, nitrogen, and oxygen, the building blocks of organic chemistry, were created in the cores of medium-sized stars through the slow fusion of helium nuclei. Silicon, magnesium, and iron, the primary components of rocky planets, were synthesized in the final stages of massive stellar evolution, when the stellar cores became hot enough to fuse progressively heavier elements. The heaviest elements, those beyond iron in the periodic table, require even more extreme conditions. Some are created in the final moments of a massive star's life, when the core collapse and rebound creates temperatures and pressures even greater than those found in normal stellar cores. Others are forged in the collision of neutron stars, when two of these incredibly dense objects spiral into each other and merge in a catastrophic explosion called a kilonova. These rare events scatter gold, platinum, and other precious metals across space, seeding future generations of stars and planets with these exotic elements. Recent observations have revealed the beauty and violence of these cosmic processes in unprecedented detail. The Hubble Space Telescope has captured images of dying stars shedding their outer layers in elegant spirals and complex geometric patterns. The James Webb Space Telescope is now peering into the hearts of stellar nurseries, watching planets form in the dusty disks surrounding young stars. Ground-based observatories equipped with adaptive optics can track the motion of individual stars as they orbit the supermassive black hole at the center of our galaxy, their paths bent by gravitational forces 1,000,000 times stronger than anything we experience on Earth. These observations have confirmed that the universe is a vast recycling system, constantly transforming simple elements into complex ones, constantly creating new opportunities for structure and complexity to emerge. The cosmic dust that falls on Earth every day is not just debris from space, but a continuing connection to this grand process of cosmic evolution. Every grain of cosmic dust that lands on your roof, every micrometeorite that burns up in Earth's atmosphere, carries with it the chemical fingerprints of stellar processes that occurred billions of years ago in distant parts of the galaxy. This cosmic recycling operates on multiple scales simultaneously. On the largest scales, entire galaxies exchange material through gravitational interactions, stellar winds, and the explosive feedback from supernovae and active galactic nuclei. Our own Milky Way galaxy is currently in the process of consuming several smaller satellite galaxies, incorporating their stars and gas into our own galactic structure. Meanwhile, our galaxy is slowly approaching the Andromeda Galaxy, and in about 4 billion years, these two massive stellar systems will collide and merge, creating an entirely new galaxy with a different structure and different patterns of star formation. On intermediate scales, individual stellar systems, like our own solar system, continue to evolve and change. The sun is gradually brightening as it ages, and in about 1 billion years, it will become hot enough to boil away Earth's oceans. Eventually, in about 5 billion years, the sun will exhaust its nuclear fuel and begin to expand into a red giant star, possibly engulfing the inner planets. When the sun finally dies, it will shed its outer layers as a planetary nebula, returning much of its material to the interstellar medium to be incorporated into future generations of stars. On the smallest scales, the atoms in our bodies are constantly being replaced through biological processes. The carbon in your muscles is exchanged with the atmosphere through respiration. The calcium in your bones is continuously deposited and reabsorbed. The water in your cells is replaced every few weeks. You are not a static collection of atoms, but a dynamic pattern, a temporary organization of cosmic material that maintains its structure through constant exchange with the environment. This dynamic nature of matter and energy extends to the cosmic scale as well. The universe itself is not a static collection of stars and galaxies, but an evolving system, constantly creating new structures and new possibilities for complexity to emerge. The cosmic microwave background radiation, the afterglow of the Big Bang, provides a snapshot of the universe when it was only 380,000 years old, a smooth and nearly featureless sea of hydrogen and helium. From this simple beginning, gravity and the other fundamental forces have sculpted the rich tapestry of structure we see today. Galaxies, stars, planets, and ultimately life itself. The story of cosmic dust and stardust is ultimately a story about connection and continuity. Every atom in your body connects you to the deaths of ancient stars, to the formation of planets, to the emergence of life on Earth, and to the future evolution of the universe. You are not just an observer of cosmic processes, but a participant in them, a temporary arrangement of stellar material that has somehow achieved the remarkable ability to contemplate its own cosmic origins. As you drift towards sleep tonight, surrounded by the quiet darkness of your room, remember that you are never truly alone. You are part of an ancient story that began with the Big Bang and continues to unfold in the formation of new stars, new planets, and new possibilities for life and consciousness to emerge. The cosmic dust that falls silently through Earth's atmosphere connects you to this grand narrative, reminding you that you are both infinitesimally small in the context of the universe and absolutely essential to its ongoing story of evolution and discovery. In the gentle rhythm of your breathing, in the steady beating of your heart, in the quiet electrical activity of your dreaming brain, the universe continues its ancient dance of creation and destruction, of death and rebirth, of cosmic recycling that has been going on for billions of years and will continue for billions more. You are Stardust, temporarily conscious, briefly aware of your cosmic heritage, and peacefully returning to the dreams from which all matter and energy emerged in the first moments after the Big Bang. Welcome back to the Sleepy Scientist, where curiosity meets calm and cosmic wonders drift gently into dreams. I'm so glad you found your way here tonight, settling in wherever you are in this vast universe of ours. Before we begin our journey, I'd love to know where in the world you're listening from and what time it is in your corner of the cosmos. Drop a comment below and let me know. There's something magical about knowing we're all connected under the same starlit sky. Tonight, we're embarking on a particularly intimate voyage, one that brings the entire universe right to your doorstep. We're exploring cosmic dust and stardust, those invisible architects that have been quietly building everything around us for over 13 billion years. These aren't just specks floating in space. They're the very foundation of reality itself, the universe's smallest but most essential construction workers. If you find tonight's journey soothing, intriguing, or simply a lovely way to drift towards sleep, I'd be ever so grateful if you gave this video a gentle like and perhaps subscribed. It helps other weary souls find their way to this peaceful corner of the cosmos. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll know something profound about your place in the universe before morning comes. So take a deep breath, let your shoulders drop, and prepare to discover how you are intimately connected to stars that died billions of years ago. Because tonight we're going to explore how cosmic dust doesn't just fill the space between stars, it fills the space between your atoms, flows through your veins, and whispers the ancient story of stellar death and rebirth in every breath you take. The story begins not with a bang, but with a whisper, the gentle sigh of a dying star as it releases its life's work into the cosmic wind. Picture this. Somewhere in the depths of space, A massive star has spent millions of years burning hydrogen into helium, helium into carbon, carbon into oxygen, and so on, up the periodic table. It's been a stellar alchemist, transforming the simplest elements into the complex ingredients needed for planets, oceans, and eventually life itself. But like all great artists, this star cannot create forever. Eventually, it runs out of fuel, and when it does, something extraordinary happens. The star doesn't simply fade away like a candle in the wind. It explodes in a magnificent supernova, one of the most powerful events in the universe. In those final moments, as the star's core collapses and then rebounds in a spectacular explosion, it creates elements heavier than iron, gold, silver, uranium, and hurls them into space at tremendous speeds. This stellar death becomes cosmic birth. The explosion sends a shockwave racing through space, carrying with it all the elements the star spent its lifetime creating. These elements, now in the form of infinitesimally small particles, become what we call stardust. They drift through the galaxy like cosmic snow, settling into the spaces between stars, mixing with hydrogen and helium left over from the Big Bang, and beginning their next chapter as the building blocks of new worlds. But the story doesn't end with supernovae. Even smaller stars, those too modest to explode dramatically, contribute to this cosmic recycling program. As they age, they puff off their outer layers in gentle, colorful displays called planetary nebulae. These stellar exhales release clouds of enriched gas and dust, adding their own contributions to the interstellar medium. It's a more subtle process than a supernova, but no less important, like a master chef slowly adding spices to a cosmic soup that's been simmering for billions of years. What makes this process so remarkable is its patience. The elements scattered by dying stars don't rush to form new worlds immediately. Instead, they drift through space for millions, sometimes hundreds of millions of years, mixing and mingling with other stellar contributions. Gravity slowly pulls them together into vast, dark clouds called molecular clouds, stellar nurseries where new stars and planets will eventually be born. Within these clouds, something beautiful happens. The dust particles, now rich with heavy elements, begin to stick together. They form the cores around which larger structures can grow, like seeds in a cosmic garden. Some will become the hearts of new stars. Others will clump together to form the rocky foundations of planets. The iron in these particles will one day flow through the veins of living creatures. The carbon will form the backbone of organic molecules. The oxygen will fill the lungs of beings not yet imagined. This is the cosmic recycling program that has been running for over 13 billion years. Every atom in your body, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now, was forged in the nuclear furnace of a star that lived and died long before our solar system was even a whisper in the cosmic wind. You are not separate from the universe. You are the universe becoming aware of itself, stellar material that has learned to contemplate its own origins. The dust that settles on your windowsill, the elements that make up the device you're listening on, the very thoughts flowing through your mind. All of it can trace its lineage back to those ancient stellar death scenes. We are all connected by this invisible thread of cosmic ancestry, all of us children of the same stellar generations, all of us temporary gatherings of stardust that will one day return to the cosmic cycle. And this process continues even now. As you listen to these words, somewhere in the galaxy, a star is dying and enriching space with its elemental gifts. Somewhere else, those gifts are condensing into new worlds. The universe is constantly recycling itself, constantly creating new possibilities from the ashes of the old, constantly writing new chapters in the endless story of cosmic evolution. This is why Carl Sagan's famous words ring so true. We are made of star stuff, not metaphorically, but literally. Every atom in your body was forged in stellar fire, scattered through space by stellar death, and gathered together by cosmic forces into the remarkable arrangement that is you. You carry within yourself the memory of ancient stars, the legacy of cosmic processes that began when the universe was young and will continue long after our sun has grown cold. So as you drift towards sleep tonight, remember that you are both infinitesimally small and cosmically significant. You are a brief but beautiful gathering of stardust, a temporary symphony of stellar elements that somehow learned to love, to dream, to wonder about its own origins. And when you wake tomorrow, you'll carry with you the quiet knowledge that you are intimately connected to every star in the sky, every grain of cosmic dust, every distant galaxy spinning in the darkness. The universe didn't just create you. You are the universe, experiencing itself through your eyes, contemplating its own beauty through your thoughts, and finding peace in the gentle recognition that we are all, quite literally, made of the same stellar dreams. Sleep well, fellow Stardust. The cosmos is vast, but tonight it feels remarkably close, flowing through your veins and whispering ancient stories in the rhythm of your heartbeat. Welcome back, fellow star travelers. As we drift deeper into our cosmic story, we find ourselves at a profound crossroads in the universe's history. We've journeyed through the birth of galaxies, watched as they learned to dance with one another across the void, and now we must turn our attention to something far more intimate, far more personal. Because within all this grand celestial architecture, within these swirling cities of stars, something extraordinary was quietly taking shape. The universe was preparing to know itself. You see, while galaxies were busy forming their elegant spirals and merging in slow-motion ballet, a quieter revolution was unfolding. Stars were not just shining, they were cooking. Deep within their cores, in furnaces hot enough to fuse atoms together, the first heavy elements were being born: carbon, oxygen, silicon, iron, all the essential ingredients for something the universe had never seen before: complexity. For billions of years, the cosmos had been relatively simple: hydrogen, helium, and the occasional lithium atom drifting through space. But now, as the first generation of massive stars reached the end of their brief, brilliant lives, they began to scatter these precious heavy elements into the void. When these ancient giants exploded as supernovae, they painted the surrounding space with the raw materials of worlds to come. This process, which scientists call stellar nucleosynthesis, was nothing short of miraculous. Every carbon atom in your body was forged in the heart of a dying star. Every oxygen molecule you breathe was created in the final moments of a stellar explosion. The calcium in your bones, the iron in your blood, the silicon in the rocks beneath your feet. All of it born in the nuclear furnaces of stars that lived and died long before our sun was even a whisper in a cosmic cloud. But here's where the story becomes truly remarkable. These scattered elements didn't simply drift aimlessly through space. Gravity, that patient sculptor we've come to know so well, began to gather them into new clouds, new possibilities. And within these enriched clouds of gas and dust, something unprecedented began to happen. The second generation of stars that formed were different. They were surrounded by disks of material, swirling pancakes of dust and gas that would eventually coalesce into something the universe had never seen: planets. Now, you might wonder, how do we know all this happened? After all, we're talking about events that occurred billions of years ago, in places so distant that their light has only just reached us. The answer lies in the cosmic dust itself. This isn't the mundane dust you might find under your sofa, though they share more in common than you might think. Cosmic dust consists of tiny particles, often smaller than the width of a human hair, composed of silicates, carbon compounds, and frozen gases. These microscopic grains are everywhere. They drift between stars. They spiral in the disks around young suns. They're swept up by comets and asteroids. And yes, they even settle gently onto the surfaces of planets like Earth. In fact, several tons of cosmic dust fall to Earth every single day, a gentle rain of stardust that connects us directly to the wider universe. But cosmic dust is far more than just stellar debris. It serves as the universe's construction material, the building blocks from which planets, moons, and eventually life itself would emerge. In the cold depths of space, these tiny grains serve as gathering points for other atoms and molecules. Water vapor condenses onto their surfaces, creating ice-coated particles. Complex organic molecules form in their shadows, protected from harsh stellar radiation. Within the swirling disks around young stars, cosmic dust begins to stick together. First in tiny clumps, then in larger aggregations, eventually forming pebbles, then boulders, then planetesimals, the kilometer-sized bodies that would eventually become the cores of planets. It's a slow process, requiring millions of years of gentle collisions and gravitational nudging. But the results are extraordinary. Scientists have learned to read the story written in cosmic dust like a library of the universe's history. By studying the composition of dust grains found in meteorites, they can determine where and when they formed. Some grains are older than our solar system itself, having drifted through space for billions of years before being incorporated into the disk of material that would eventually become Earth. These pre-solar grains, as they're called, are like tiny time capsules. They carry within their crystalline structures the isotopic signatures of their parent stars, some formed in the atmospheres of red giant stars, others in the explosive environments of supernovae. Each grain tells a story of stellar death and rebirth, of elements forged in nuclear fire and scattered to the cosmic winds. But perhaps most remarkably, cosmic dust played a crucial role in making planets habitable. In the early solar system, dust grains helped regulate temperature by absorbing and re-radiating heat. They provided surfaces for chemical reactions that wouldn't have been possible in empty space. And they delivered water and organic compounds to the inner planets, seeding them with the raw materials for life. The story of cosmic dust is ultimately the story of connection. Every speck of dust that drifts between the stars carries with it the history of the universe. It connects the death of ancient stars to the birth of new worlds. It links the nuclear furnaces of stellar cores to the gentle chemistry of planetary surfaces. And in a very real sense, it connects you to the cosmos itself. When you look up at the night sky, you're not just seeing distant points of light. You're seeing the sources of the very atoms that make up your body. The calcium in your teeth was forged in a stellar explosion. The oxygen in your lungs was created in the core of a massive star, and the carbon that forms the backbone of every organic molecule in your body was cooked in the nuclear furnace of a dying giant. This isn't mere poetry, though it certainly is poetic. It's a profound scientific truth that reveals our deep connection to the universe. We are not separate from the cosmos, observing it from the outside. We are part of it, made from it, connected to it in the most fundamental way possible. We are the universe becoming aware of itself, star stuff contemplating its own origins. As you settle into sleep tonight, let this thought comfort you. You are not alone in the darkness. You carry within you the light of ancient stars, the memory of cosmic fires, the dust of distant worlds. Every breath you take connects you to the vast web of stellar recycling that has been going on for billions of years. You are, quite literally, made of magic, forged in the hearts of stars and scattered across space to eventually become conscious, thinking, dreaming. The cosmic dust that fell to Earth today will tomorrow become part of the soil, part of the plants, part of the endless cycle of matter that connects all things. And perhaps, millions of years from now, some of the atoms that currently make up your body will drift once again between the stars, carrying with them the story of a species that once looked up at the night sky and wondered about their place in the cosmos. In this gentle rain of stardust, in this constant exchange of matter between Earth and space, we find one of the most beautiful metaphors for our existence. We are temporary arrangements of cosmic material, brief patterns in the endless dance of atoms that has been going on since the first stars lit up the darkness. But in our brief moment of consciousness, we have the extraordinary privilege of understanding this dance, of seeing our place in it, and of sharing that wonder with one another. So sleep peacefully, knowing that you are part of something much larger and more beautiful than you might have imagined. The universe is not empty space punctuated by isolated stars and planets. It is a living, breathing, ever-changing tapestry of matter and energy, constantly recycling itself, constantly creating new possibilities. And you, dear traveler, are one of those possibilities, a unique and precious arrangement of stardust that has learned to love, to dream, and to wonder at the beauty of it all. Welcome to the gentle frontier where science meets slumber, where the smallest particles in the universe build the grandest structures, and where every breath you take connects you to the cosmic story that began billions of years ago. Tonight, we're drifting through space and time to explore the universe's most humble yet essential architects, cosmic dust and stardust. You might think of dust as something mundane, perhaps the thin layer that gathers on your bookshelf or dances in afternoon sunlight streaming through your window. But cosmic dust is different. It's ancient, it's traveled impossible distances, and it carries within it the very essence of creation itself. Every speck tells a story of stellar birth, stellar death, and the endless recycling of matter that makes galaxies, planets, and ultimately life possible. The dust grains floating between the stars are not just debris. They are the universe's construction workers, quietly building the scaffolding for everything we see. They seed the formation of new stars, they carry the elements necessary for rocky planets, and they even help create the complex molecules that life depends upon. In many ways, these tiny particles, invisible to the naked eye, are responsible for the magnificent cosmos we observe today. But here's where it gets truly poetic. You are made of this dust, not metaphorically, but literally. The carbon in your cells, the iron in your blood, the calcium in your bones, all of it was forged in the hearts of ancient stars and scattered into space as cosmic dust. You are, quite genuinely, made of stardust, and tonight we'll trace that remarkable journey from stellar cores to your very existence. The story begins not with dust, but with fire. Deep within the cores of stars, temperatures soar to millions of degrees, and pressures become so intense that the very fabric of matter transforms. Here, in these stellar furnaces, the universe's most important alchemy takes place, nucleosynthesis, the process by which simple elements are forged into more complex ones. When the universe was young, just minutes old, it contained primarily hydrogen and helium, with traces of lithium. These were the only elements that emerged from the Big Bang's primordial furnace. But stars changed everything. As gravity pulled clouds of hydrogen and helium together, the first stars ignited, and within their cores, fusion began to work its magic. In the heart of a star, hydrogen nuclei collide with such force that they overcome their natural repulsion and fuse together, creating helium and releasing tremendous amounts of energy. This is the process that makes stars shine, but it's also the beginning of element creation. As a star ages and its core grows hotter, it begins fusing helium into carbon, then carbon into oxygen. oxygen into silicon, and so on, climbing up the periodic table. Each fusion reaction requires higher temperatures and pressures than the last. The most massive stars, those at least 8 times the mass of our Sun, can continue this process all the way up to iron. Their cores become like nested Russian dolls, with shells of different elements burning at different temperatures. The outermost shell burns hydrogen into helium, the next burns helium into carbon, then carbon into oxygen, and so forth until you reach the innermost core where silicon fuses into iron. But iron is special. It sits at the peak of nuclear binding energy, which means that fusing iron into heavier elements doesn't release energy. It actually requires energy. When a massive star's core fills with iron, fusion suddenly stops. The core can no longer support itself against gravity's relentless pull, and in less than a second, it collapses catastrophically. What happens next is one of nature's most spectacular events, a supernova explosion. The collapsing core rebounds in a shockwave that tears through the star, heating the outer layers to billions of degrees and creating conditions so extreme that elements heavier than iron can finally form. Gold, silver, platinum, uranium, all the heavy elements that make our world so richly complex, are forged in these moments of stellar death. The explosion doesn't just create these elements, it hurls them into space at thousands of kilometers per second. The star's outer layers, now enriched with newly formed elements, are blasted into the surrounding interstellar medium, creating expanding bubbles of hot, glowing gas called supernova remnants. These remnants can shine for thousands of years, slowly cooling and mixing their enriched material with the ambient gas of space. But supernovae aren't the only stellar contributors to the cosmic dust supply. Lower mass stars, like our own Sun, follow a gentler path to element dispersal. As they age, they expand into red giants, their outer layers becoming cool and extended. In these cooler regions, elements can condense into tiny solid grains, the first cosmic dust particles. Eventually, these aging stars shed their outer layers entirely, creating beautiful planetary nebulae, glowing shells of gas and dust that drift away from the dying star's core. The central star, now a white dwarf, slowly fades over billions of years, but the elements it created and dispersed continue their journey through space. These gentler stellar deaths contribute significantly to the universe's supply of carbon, nitrogen, and oxygen, elements essential for life as we know it. The dust grains created in these stellar outflows are incredibly small, typically just a few tens to hundreds of nanometers across. To put that in perspective, if a dust grain were the size of a marble would be the size of the Earth. Yet despite their minuscule size, these grains play an outsized role in cosmic evolution. As they drift through space, cosmic dust grains serve as tiny laboratories for chemistry. Their surfaces provide meeting places where atoms can stick and react, forming more complex molecules than would be possible in the sparse conditions of interstellar space. Simple molecules like water, methane, and ammonia form on grain surfaces, as do more complex organic compounds, including amino acids and other prebiotic molecules. The dust also plays a crucial role in star formation itself. Interstellar space is not empty. It's filled with vast clouds of gas and dust called molecular clouds. These clouds are cold, just a few degrees above absolute zero, and incredibly tenuous. But within them, dust grains serve as coolants, radiating away heat and allowing the gas to collapse under its own gravity. Without dust, these clouds would be too hot to collapse, and new stars would never form. The dust grains absorb starlight from nearby stars and re-emit it as infrared radiation, cooling the surrounding gas and allowing gravity to pull it together into denser clumps. As these clumps grow denser, they eventually reach the point where nuclear fusion can ignite, and a new star is born. But the dust doesn't disappear when a star forms. Much of it remains in a disk around the young star, and within this disk, the process of planet formation begins. The dust grains stick together through electrostatic forces and gentle collisions, growing from microscopic specks into pebbles, then boulders, then planetesimals, and eventually full-size planets. This is how Earth formed, roughly 4.5 billion years ago. Our planet began as countless tiny dust grains that slowly accumulated in the disk around the young sun. The iron in Earth's core, the silicon in its rocks, the carbon in its atmosphere, and life forms. All of it started as stardust, forged in stellar cores and dispersed by stellar death. And the process continues today. Earth is constantly being bombarded by cosmic dust, accumulating roughly 40,000 tons of it every year. Most of these particles are so small, they simply drift down through the atmosphere, but some are large enough to create the shooting stars we see streaking across the night sky. These meteors are cosmic dust grains burning up as they enter our atmosphere at tremendous speeds, briefly becoming incandescent and visible from the ground. Some of this cosmic dust survives its journey through the atmosphere and reaches Earth's surface. Scientists have found these microscopic particles in ice cores, deep sea sediments, and even on rooftops. Each grain is a messenger from space, carrying information about the stars and processes that created it. By studying these particles in the laboratory, we can learn about stellar nucleosynthesis, supernova explosions, and the chemical evolution of the galaxy. The story of cosmic dust is also the story of the universe's chemical evolution. When the first stars formed, they contained only hydrogen and helium. But when they died, they enriched the interstellar medium with heavier elements. The next generation of stars formed from this enriched material, and when they died, they added even more heavy elements to the cosmic mix. This process has continued for over 13 billion years, gradually increasing the abundance of heavy elements in the universe. Astronomers call this process metallicity, and they can trace it by observing stars of different ages. The oldest stars in our galaxy have very low metallicity. They contain very few elements heavier than hydrogen and helium. Younger stars like our Sun have much higher metallicity, containing the accumulated products of billions of years of stellar nucleosynthesis. This chemical evolution has been essential for the development of complexity in the universe. The first generation of stars could not have rocky planets because there were no heavy elements to build them from. Life as we know it could not have existed because there was no carbon, oxygen, or nitrogen. It took multiple generations of stellar death and rebirth to create the rich chemical environment that makes planets like Earth possible. Welcome back to The Sleepy Scientist, where cosmic wonder meets cosmic slumber. Tonight, we're continuing our gentle drift through the universe's most mysterious builders. I hope you're settling in comfortably, perhaps with a warm cup of tea, or simply the quiet satisfaction of another day coming to its peaceful close. We've journeyed through the birth of stars, watched them scatter their precious elements across the cosmos, and seen how these tiny particles begin their long, patient work of construction. But now, as we drift further through this cosmic story, we encounter something truly remarkable. The moment when all this scattered stardust begins to gather, to organize, to build something entirely new. Picture, if you will, a vast cosmic construction site. Not the noisy, chaotic kind you might imagine, but something far more graceful. Billions of years have passed since the first massive stars exploded, painting space with the heavy elements that would become the ingredients for everything we know. Carbon, oxygen, silicon, iron, and dozens of other elements now drift through the galaxy like an invisible fog, waiting patiently for gravity's gentle invitation to dance. In the cold depths of space, far from any star's warming light, something beautiful is beginning to happen. Those scattered atoms, Those ancient remnants of stellar fire are starting to find each other. It's not a hurried process, nothing in the cosmos ever is. Instead, it's a slow, elegant waltz of matter responding to the universe's most fundamental force. Gravity, that persistent sculptor we've met before, begins to gather these atoms into increasingly dense clouds. At first, these clouds are vast and tenuous, spanning light years but containing less matter than you'd find in a single breath of Earth's atmosphere. But time is patient, and gravity is relentless. Slowly, ever so slowly, these clouds begin to collapse under their own weight. As they collapse, something wonderful happens. The atoms begin to stick together, forming the first solid particles the universe has seen since the Big Bang's earliest moments. These aren't just any particles, though. They're dust grains, microscopic specks of matter that will become the universe's most versatile building blocks. Each grain is smaller than anything you could see with the naked eye, yet within these tiny structures lies the potential for worlds. The process is surprisingly delicate. In the cold of space, atoms can bond together in ways that would be impossible in the heat of a star or the warmth of a planet's surface. Hydrogen atoms find oxygen atoms and form water ice. Carbon atoms link together in long chains or settle into crystalline structures. Silicon and oxygen dance together to create the minerals that will one day form the rocky hearts of planets. These dust grains are born in a universe that seems almost impossibly hostile to their formation. Space is vast, cold, and mostly empty. The density of matter is so low that on Earth we'd call it a perfect vacuum. And yet, against these odds, matter organizes itself. It's as if the universe has an innate desire to build, to create complexity from simplicity, structure from chaos. What makes this process even more remarkable is its variety. Different regions of space with different temperatures and different mixtures of elements produce different types of dust. Near the warm glow of young stars, you might find grains rich in carbon, forming tiny diamonds or graphite particles. In the colder outer reaches of stellar nurseries, water ice dominates, creating fluffy, snow-like particles that drift through space like cosmic snowflakes. Silicon and oxygen, those reliable partners in cosmic construction, form the backbone of many dust grains. These silicate particles are remarkably similar to the minerals found in Earth's rocks, which isn't surprising when you remember that Earth itself was built from this same cosmic dust billions of years ago. Every grain of sand on a beach, every crystal in a mountain, every pebble beneath your feet was once floating in the dark between stars. The iron scattered by dying stars finds its way into these dust grains too, sometimes forming tiny metallic particles, other times incorporating itself into more complex mineral structures. This iron will eventually become part of planets, part of living creatures, part of the blood flowing through your veins as you listen to these words. It's a connection that spans billions of years and countless light years, linking you directly to the ancient stars that died to make your existence possible. But dust grains aren't just passive participants in this cosmic construction project. They're active builders, catalysts that make further construction possible. In the cold depths of space, atoms that would normally repel each other can meet and bond on the surface of a dust grain. The grain acts like a cosmic workbench, holding atoms in place long enough for them to form more complex molecules. This is where the chemistry of life begins to take shape. On the surfaces of dust grains, simple molecules grow into more complex ones. Water forms, then ammonia, then methanol, then even more elaborate organic compounds. These grains become tiny laboratories experimenting with molecular recipes that will eventually lead to the emergence of life itself. As these dust-rich clouds continue to evolve, they begin to show structure. Turbulence in the gas creates eddies and currents, concentrating dust in some regions while leaving others relatively empty. Magnetic fields thread through the clouds, guiding the movement of charged particles and shaping the distribution of matter. What was once a uniform fog begins to develop personality, character, the seeds of future complexity. The dust itself begins to evolve too. Grains collide and stick together, growing larger and more complex. They develop mantles of ice and organic molecules, becoming fluffy, irregular particles that look nothing like the smooth spheres you might imagine. Some grow to be quite large by cosmic standards, perhaps 1,000th of a millimeter across, making them visible in the most powerful microscopes if you could somehow collect them. These growing dust particles start to affect their environment in subtle but important ways. They absorb starlight and re-emit it as infrared radiation, cooling the gas around them. This cooling is crucial because it allows the gas to contract more easily under gravity's pull. In a sense, the dust is preparing its own future home, creating the conditions that will allow stars and planets to form. The process is slow beyond human comprehension. A single dust grain might drift through space for millions of years before encountering another grain to collide with. The clouds themselves evolve over timescales that dwarf human civilization. Yet this patience is part of the beauty. The universe doesn't rush. It takes the time needed to build things properly, to create structures that will endure for billions of years. And as these clouds grow denser and more structured, as their dust grains multiply and evolve, they're preparing for the next great chapter in cosmic construction. Eventually, gravity will pull these clouds together so tightly that they'll collapse, forming the dense cores where new stars will ignite. When that happens, the dust will find itself in a new environment, heated by starlight, stirred by stellar winds, beginning its transformation into something even more remarkable. But that transformation is still to come. For now, in the quiet depths of space, dust grains continue their patient work. They gather atoms, build molecules, and prepare the raw materials for worlds yet to be born. They're the universe's craftsmen, working in darkness and silence, building the future one atom at a time. As you drift towards sleep tonight, perhaps you can imagine them out there, these tiny builders, working in the vast spaces between stars. Each grain carries within it the memory of ancient stars and the promise of future worlds. They're writing the next chapter of the cosmic story, and in a very real sense, they're writing your story too. For you are made of the same stardust, shaped by these same forces, part of the same grand construction project that began with the first stars and continues even now in the gentle darkness of a universe that never stops building, never stops dreaming, never stops reaching towards something beautiful and new. We've journeyed far through the cosmic tapestry, from the birth of the first stars to the graceful dance of galaxies across billions of years. We've explored how these tiny specks of dust and scattered atoms became the building blocks of everything we see, including the very elements that flow through your veins as you listen to these words tonight. But there's something almost poetic about how our story comes full circle. Those ancient cosmic processes we've been exploring, the patient accumulation of dust into stars, the gentle coalescence of matter guided by gravity's invisible hand, they're still happening right now, all around us, in ways both grand and surprisingly intimate. Consider the air you're breathing as you settle into sleep. Every molecule of oxygen was forged in the nuclear furnace of a star that lived and died billions of years ago. The carbon in your body was created when massive stars collapsed in brilliant supernovae, scattering their enriched contents across space like cosmic dandelion seeds. The iron in your blood was born in those same stellar explosions, cooled in the depths of space, and eventually found its way to a small blue planet where it became part of you. This isn't just metaphor or poetic license, it's the literal truth of your cosmic heritage. You are, quite genuinely, made of stardust, not in some vague spiritual sense, but in the most concrete, scientific way possible. The calcium in your bones, the phosphorus in your DNA, the sulfur in your proteins, all of it was assembled in stellar cores and distributed by stellar winds and supernovae across the galaxy. And here's what makes this even more remarkable. This cosmic recycling continues today. Even as you rest, cosmic dust particles are drifting down through Earth's atmosphere, adding their ancient stories to our planet's ongoing narrative. Thousands of tons of cosmic dust settle on Earth every year, carrying with them the chemical signatures of distant stars, far-off galaxies, and processes that began when the universe was young. Some of this dust comes from our own solar system, remnants of the nebula that gave birth to the sun and planets 4.5 billion years ago. But some of it has traveled much farther. Presolar grains, tiny diamonds, and silicon carbide crystals that formed around dying stars have been found in meteorites. These microscopic time capsules preserve the nuclear fingerprints of stars that died before our solar system was even a whisper in the cosmic wind. When you look up at the night sky, you're not just seeing points of light scattered across darkness. You're witnessing the ongoing construction project of the universe. New stars are being born in stellar nurseries like the Orion Nebula, where gravity is still doing what it has always done, gathering cosmic dust and gas into dense knots that will eventually ignite as nuclear furnaces. Other stars are ending their lives, enriching space with heavier elements that will become the raw materials for future generations of stars, planets, and perhaps life itself. This process of cosmic recycling operates on timescales that dwarf human experience, yet it connects us intimately to the deepest history of the universe. The atoms in your left hand may have formed in different stars than those in your right hand. You are quite literally a collection of ancient stellar debris, organized by billions of years of chemistry and biology into something capable of consciousness, wonder, and the ability to contemplate its own cosmic origins. And this brings us to perhaps the most beautiful aspect of our cosmic dust story. We are not separate from the universe, looking in from the outside. We are the universe looking at itself. Every time you gaze up at the stars, every time you wonder about your place in the cosmos, you are cosmic dust that has organized itself into a form capable of curiosity. You are the universe's way of knowing itself, of appreciating its own beauty and complexity. The dust that swirls in a beam of sunlight streaming through your window carries the same fundamental ingredients as the dust that forms new stars in distant galaxies. The water you drink contains hydrogen that has been cycling through the cosmos since the first few minutes after the Big Bang. The very thoughts you're thinking right now are patterns of electrical activity in a brain built from elements that were scattered across space by dying stars. This perspective transforms everything. Your daily life, your relationships, your dreams and aspirations, they're all part of this grand cosmic story. Every breath you take is an exchange with the universe itself. Every moment of consciousness is a brief flowering of cosmic dust into awareness, a temporary arrangement of ancient atoms into something capable of love, creativity, and wonder. As you drift towards sleep tonight, imagine yourself as part of this vast, patient process. Your body will rest, but the atoms that compose you will continue their ancient dance, the same dance they've been performing since the first stars lit up the darkness. And when morning comes, you'll wake as a slightly different arrangement of cosmic dust, carrying within you the accumulated wisdom of billions of years of stellar evolution. The cosmic dust that forms new stars operates on cycles measured in millions and billions of years. But you, in your brief moment of consciousness, experience the universe at a different scale. Your heartbeat, your breath, your thoughts, they happen in seconds and minutes and hours. Yet both timescales are part of the same story, nested within each other like Russian dolls of cosmic time. And perhaps that's the most comforting thought of all. You are not an accident or an afterthought in the cosmic story. You are its inevitable flowering, the natural result of dust and gravity and time working together to create something beautiful. The same processes that build stars and planets and galaxies have built you, and through you, the universe has gained the ability to wonder at its own magnificence. So rest well tonight, fellow Stardust. Tomorrow, the ancient cosmic processes will continue their patient work, building new worlds from the scattered remains of old ones. And you'll be part of it all, carrying within your very atoms the memory of stars that shone before the earth was born, contributing your brief but precious moment of consciousness to the universe's long, slow dream of understanding itself. The smallest builders in the universe, the cosmic dust grains we've been exploring, remind us that the grandest structures often emerge from the humblest beginnings. From dust to stars, from stars to planets, from planets to life, from life to consciousness, from consciousness to wonder. It's a chain of becoming that connects you directly to the Big Bang itself and forward to futures we can barely imagine. Sleep peacefully in that knowledge. You are home in the universe because you are made of the universe. Every atom in your body is a small piece of cosmic history, and every breath you take is a gentle exchange with the infinite. The stars that shine above you tonight are your distant relatives, and the dust that dances in tomorrow's sunlight carries the same ancient story that flows through your veins. You are cosmic dust, briefly awakened to consciousness, contemplating your own cosmic origins. And there's something profoundly beautiful about that fact, something that makes every moment of awareness a small miracle, a tiny victory for the universe's long, patient journey toward understanding itself through eyes like yours. Now we venture into the final frontiers of our cosmic story, where the tiniest particles reveal their most profound secrets. The dust grains that survived the journey through interstellar space didn't simply arrive at random destinations. They carried with them the chemical fingerprints of their stellar origins, and when they became incorporated into new worlds, they brought the building blocks of complexity itself. On countless worlds throughout the universe, cosmic dust settled into the primordial materials that would eventually form planets. But dust alone wasn't enough. It needed time, pressure, and the gentle alchemy of planetary formation to transform these stellar remnants into something even more remarkable, the foundation for life itself. Consider the extraordinary chemistry hidden within these ancient grains. The carbon forged in the hearts of dying stars didn't remain as simple carbon atoms. Through the patient work of cosmic processes, it combined with oxygen to form carbon monoxide, with hydrogen to create organic molecules, and with other elements to build the complex compounds that would one day become the backbone of biological systems. The iron scattered by supernovae found its way into planetary cores, creating magnetic fields that would protect future atmospheres from harmful radiation. The oxygen breathed by early microorganisms came from dust that had drifted through space for millions of years. Even the calcium in bones and the phosphorus in DNA can trace their lineages back to specific types of stellar explosions. But perhaps most remarkably, cosmic dust didn't just provide the raw materials for life. It also served as the delivery system for some of life's most essential components. Interstellar dust grains, when they form in the cold depths of space, become coated with thin layers of ice. This isn't ordinary ice, but a complex mixture of water, methanol, ammonia, and even simple organic compounds like formaldehyde and hydrogen cyanide. These ice-coated grains act like tiny chemical laboratories, floating through space for millions of years. Cosmic radiation slowly drives chemical reactions on their surfaces, building increasingly complex molecules. Some of these reactions produce amino acids, the building blocks of proteins. Others create nucleotide bases, the fundamental components of DNA and RNA. When these enriched dust grains eventually find their way to planetary surfaces, through comet impacts or direct accretion, They deliver not just elements, but preformed biological molecules. It's as if the universe had been preparing care packages for billions of years, filling them with everything needed to kickstart the chemistry of life. This process continues even today. Every year, Earth receives thousands of tons of cosmic dust, much of it carrying organic compounds formed in the depths of space. Meteorites regularly deliver amino acids and other biological precursors to our planet's surface. The boundary between terrestrial and cosmic chemistry is far more porous than we once imagined. The story becomes even more profound when we consider how this cosmic heritage shapes the evolution of life itself. The trace metals delivered by ancient dust grains don't just sit passively in planetary crusts. They become active participants in biological processes. Zinc enables protein folding, copper facilitates electron transport, molybdenum powers nitrogen fixation. Each of these elements was once part of a star, and each now plays a crucial role in the intricate dance of life. Even the timing of these deliveries matters. The heavy bombardment period that marked the early history of our solar system wasn't just a chaotic reign of destruction. It was also the primary mechanism by which life's essential ingredients were distributed throughout the inner planets. The same cosmic violence that scarred ancient surfaces also seeded them with the materials that would eventually give rise to forests, oceans, and civilizations. This perspective transforms our understanding of life's place in the universe. We're not isolated biological accidents on a lonely planet. We're the direct descendants of stellar processes that have been unfolding for over 13 billion years. Every cell in our bodies contains atoms that were forged in stellar furnaces, scattered by cosmic winds, gathered by gravity, and refined by planetary processes into the exquisite complexity we call life. The carbon in our DNA was once part of a dying star's atmosphere. The oxygen we breathe was expelled in a planetary nebula. The iron in our blood was created in a supernova explosion. We are not separate from the cosmos. We are the cosmos becoming aware of itself, walking around on the surface of a planet, looking up at the stars and slowly recognizing our own cosmic ancestry. This recognition carries profound implications for how we view our place in the universe. If the processes that created us are universal, operating wherever stars form and die, then the building blocks of life must be scattered throughout the galaxy. The same dust grains that seeded Earth are settling on countless other worlds, carrying the same chemical potential, the same organic precursors, the same stellar gifts. We are part of an ongoing cosmic story, one that began with the first stars and continues today in every grain of dust that drifts between the stars. The universe hasn't finished building. It's still creating, still experimenting, still scattering the seeds of future complexity across the cosmic landscape. And we, made of star stuff and carrying the memory of stellar deaths in every atom of our being, are both the products and the ongoing authors of this magnificent tale. In the quiet moments when we pause to consider our place in this vast cosmos, we might feel small and insignificant. But the truth is precisely the opposite. We are the universe's way of knowing itself, the means by which billions of years of stellar evolution have produced consciousness capable of contemplating its own origins. We are quite literally the cosmos awakening to its own story, told in the language of atoms that were born in the hearts of ancient stars. Here is part 11 of The Sleepy Scientist. Cosmic dust and stardust, the universe's smallest builders. We've traced the magnificent journey of cosmic dust from stellar nurseries to planetary surfaces, watched as these tiny particles seed new worlds and carry the chemical signatures of ancient stars across the cosmos. But now, as we drift toward the end of our gentle exploration, there's one final, deeply moving chapter to consider: how this cosmic dust doesn't just build planets and moons, but actually becomes part of something far more extraordinary. It becomes us. Every breath you're taking right now, every beat of your heart, every thought drifting through your mind as you settle into sleep is made possible by atoms that were once scattered as dust between the stars. The calcium in your bones was forged in the nuclear furnace of a dying star and scattered into space by a supernova explosion. The iron in your blood that carries oxygen through your body was created in the core of a massive star that lived and died billions of years ago. The carbon that forms the backbone of every molecule in your DNA was manufactured in the heart of an ancient red giant and released into the cosmos when that star shed its outer layers in a planetary nebula. This isn't metaphor or poetry, though it certainly feels poetic. This is literal truth. You are made of stardust, assembled from cosmic dust that has been recycling through the universe for over 4 billion years. When Carl Sagan first said we are made of star stuff, he was describing one of the most profound connections in all of science, the direct, unbroken link between the nuclear processes in stellar cores and the biological processes that keep you alive. Think about this for a moment. The hydrogen in your body, the most abundant element in your composition, was created in the first few minutes after the Big Bang. Those hydrogen atoms have been on an incredible journey. They may have spent millions of years drifting through interstellar space, been swept up into molecular clouds, collapsed to form new stars, been ejected again by stellar winds, incorporated into asteroids and comets, and eventually found their way to the early Earth, where they became part of the water in ancient oceans. From there, they may have cycled through countless generations of living organisms, been absorbed by plants, consumed by animals, returned to the soil, evaporated into the atmosphere, fallen again as rain, and finally, through the complex dance of biochemistry, became part of you. The oxygen you breathe was created in the cores of stars at least 8 times more massive than our sun. When these stars reached the end of their lives, they exploded as supernovae, scattering their oxygen-rich interiors across light years of space. Some of this oxygen became incorporated into water molecules on the early Earth. Some became part of the rocky minerals in Earth's crust, and some eventually became the oxygen that powers the cellular respiration happening in your body right now. Even more remarkably, the heavier elements in your body tell stories of the most extreme events in the universe. The gold in any jewelry you might be wearing, the silver in your dental fillings, the iodine essential for your thyroid function. These elements weren't just created in ordinary stellar nucleosynthesis. They required the incredible energies and neutron densities found only in neutron star collisions, those cosmic catastrophes we call kilonovae. When 2 neutron stars spiral into each other and merge, they create conditions so extreme that the very fabric of space-time ripples outward as gravitational waves, while simultaneously forging the heaviest elements in the periodic table and hurling them into space as expanding clouds of the most precious cosmic dust. This means that somewhere in your body, you carry atoms that were created in events so violent and energetic that they literally shook the universe itself. The gold atoms in your wedding ring, if you have one, were formed in a collision so powerful it created ripples in space-time that we can now detect with instruments like LIGO. Those atoms traveled through space for billions of years, survived the formation of the solar system, became incorporated into the Earth, and eventually, through the vast complexity of geology and biology, found their way into human civilization and onto your finger. But the connection goes even deeper than individual atoms. The very elements that make life possible, what astronomers call the CHNOPS elements, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, all have their origins in stellar processes and have been distributed throughout the galaxy by the mechanisms we've been discussing. Carbon and oxygen come from the cores of massive stars. Nitrogen is produced in smaller stars and red giants. Phosphorus, essential for DNA and cellular energy storage, is created in supernovae. Sulfur comes from the explosive burning in massive stars. These elements don't just happen to be the ingredients of life. They are life, and they are the gift of dying stars. This cosmic inheritance means that life on Earth is not separate from the universe. It is the universe becoming aware of itself. When you look up at the night sky, you're not just observing distant objects. You're seeing your own deep history, the furnaces where your atoms were forged, the stellar graveyards where your elements were scattered, the cosmic processes that eventually led to your existence. The light from those stars is hitting atoms in your eyes that may have been created in similar stars billions of years ago. The dust grains we've been discussing throughout this series, those tiny particles drifting between the stars, aren't just building blocks for planets and moons. They are building blocks for consciousness itself. Every grain of cosmic dust that settled into the early Earth's atmosphere, every meteorite that delivered organic compounds to the young planet's surface, every molecule of water brought by comets contributed to the chemical complexity that eventually gave rise to life. And this process continues today. Right now, as you listen to this, tons of cosmic dust are settling into Earth's atmosphere every day. Some of this dust carries organic molecules, complex carbon compounds that formed in the cold depths of space or in the atmospheres of dying stars. These molecules join the vast chemical inventory of our planet, adding their microscopic contributions to the ongoing story of terrestrial chemistry. What's truly remarkable is that this process of stellar recycling and cosmic dust distribution has been happening for most of the universe's history. The elements in your body have likely been through multiple generations of stars. An oxygen atom in your lungs might have been created in a star that died 8 billion years ago, incorporated into a new star system, ejected again, swept up into another molecular cloud, formed part of another star, and been expelled once more before finally becoming part of the solar nebula that formed our sun and planets. This means you are not just made of stardust, you are made of recycled stardust. You are part of an ancient cosmic economy where nothing is wasted, where every atom is precious and gets used over and over again in an endless cycle of creation, destruction, and renewal. The universe has been preparing for your existence for over 13 billion years, forging your atoms and stellar cores, scattering them through space, gathering them into new stars and planets, and finally assembling them into the complex, thinking, dreaming being that you are. Even more poetically, this connection extends beyond just the atoms in your body. The cosmic dust that facilitated star formation throughout the galaxy's history helped create the long, stable environment that allowed life to evolve on Earth. Without dust grains cooling molecular clouds and enabling star formation, without the gradual enrichment of the interstellar medium with heavy elements, without the precise dance of stellar birth and death that has maintained the galaxy's chemical evolution, complex life as we know it could never have emerged. So as you drift towards sleep tonight, carried by thoughts of cosmic dust and stellar recycling, remember that you are not just an observer of these processes. You are their culmination, their masterpiece, their most extraordinary creation. You are the universe's way of knowing itself, built from the ashes of ancient stars, animated by the energy of nuclear fusion, and connected to every corner of the cosmos through the atoms that make up your being. The cosmic dust that drifts between the stars, invisible and seemingly insignificant, has been the universe's smallest builders for billions of years, and their greatest construction project, their most magnificent achievement, is not a planet or a moon or even a star. It is you, a conscious being capable of understanding your own cosmic origins, of appreciating the beauty of the night sky, and of feeling wonder at the incredible journey that brought stardust together to create thought, emotion, and dreams. As we come to the final movement of our cosmic symphony, we find ourselves at the end of one story and the beginning of countless others. We've journeyed together through 13.8 billion years, from the first whisper of hydrogen in the primordial dark to the vast stellar cities we call galaxies, from the birth of the very elements that compose our bodies to the quiet realization that we are, quite literally, made of ancient starlight. Tonight, as you prepare to drift into sleep, I want you to carry with you this gentle truth. You are not separate from the cosmos. You are not merely an observer of this grand celestial dance. You are part of it, woven into its very fabric. Every carbon atom in your DNA was forged in the nuclear furnace of a dying star. Every calcium atom in your bones was scattered across space by a supernova's final breath. Every iron atom in your blood once pulsed through stellar cores that burned billions of years before Earth was even a glimmer of possibility. The cosmic dust we've explored together isn't just floating out there in the distant reaches of space. It's here, in this room, in your lungs, with every breath you take. It's in the water you drink, the food that nourishes you, the very thoughts flowing through your mind right now. You are cosmic dust that learned to dream, stardust that gained consciousness, the universe discovering itself through your eyes. This isn't poetry, though it sounds like it. This isn't mysticism, though it feels sacred. This is the quiet, patient work of science, revealing something almost too beautiful to believe, that we belong here, that we've always belonged here, that we are not accidents in an indifferent universe, but rather the natural and inevitable result of cosmic evolution unfolding exactly as it should. When ancient supernovae exploded in the depths of space, they didn't know they were seeding future worlds with the ingredients for life. When stellar winds carried precious metals across the galaxy, they couldn't imagine those same atoms would one day form beating hearts and curious minds. When cosmic dust grains drifted through the interstellar medium, buffeted by radiation and shaped by magnetic fields, they had no concept that they were participating in a story that would eventually include you, here now, listening to these words in the gentle darkness of your evening. The universe has been preparing for this moment for billions of years. Every stellar birth, every planetary formation, every chemical reaction in the cosmic deep was a step toward the emergence of complexity, of consciousness, of the capacity to wonder and dream and love. You are not just made of star stuff, you are the universe's way of understanding itself, of appreciating its own beauty, of marveling at its own magnificent unfolding. And here's the most beautiful part of all. This story isn't ending. Right now, even as you rest, new stars are being born from the cosmic dust we've explored tonight. New planets are condensing from stellar debris. New possibilities are crystallizing in the depths of space. The cosmic recycling continues, patient and eternal, carrying the gifts of ancient stars toward futures we can barely imagine. Somewhere in a distant nebula, atoms that once lived inside your body will find new homes. The calcium from your bones might help build the shell of an alien creature on a world not yet born. The iron from your blood might flow through the veins of continents on planets orbiting stars that haven't yet ignited. The carbon that carries your thoughts might one day form the neural networks of minds that will dream dreams we cannot fathom. You are both ancient and eternal, both temporary and timeless. You are a brief, brilliant arrangement of cosmic dust that has learned to contemplate its own origins, to feel wonder at its own existence, to find meaning in its own story. And when your time comes to return these borrowed atoms to the cosmic commons, you will not disappear. You will transform, continuing the great conversation between matter and energy, between space and time, between the universe and itself. So sleep peacefully tonight, knowing that you are exactly where you belong, when you belong, as you belong. The same forces that scattered stardust across the galaxy now cradle you in gravity's gentle embrace. The same elements that ignited the first stars now flow through your veins, carrying life and consciousness to every corner of your being. The same cosmic processes that built the galaxies now orchestrate the quiet miracle of your breathing, your dreaming, your peaceful rest. You are cosmic dust that learned to love, stardust that gained the capacity for wonder, the universe's gift to itself wrapped in the tender vulnerability of human form. Rest well, fellow traveler. The stars are singing you to sleep. The galaxies are keeping watch, and tomorrow, the ancient dance continues, with you as both witness and participant in the most beautiful story ever told. Sweet dreams, dear Stardust. The cosmos is dreaming with you.